This week in Weekly Space News, the Rosetta probe has finally arrived at Comet 67P. And the Spanish telescope confirms a planet around a red giant star really close in orbit to it. In other news, the New Horizons space probe captures Pluto and Charon. And a weather forecast for Uranus. And of course, in other things, a question from the comments of last week's video and a very special place to visit, pretty close near your own house. This is Weekly Space News. Hello everyone, this is Frostbreath reporting and welcome back to Weekly Space News, the second episode. I received quite a lot of positive feedback on the first episode, so thank you very much for that. I even received the very first question, which I will answer later on in the news. But as promised, first things first. The headlines of the news were two very interesting things that I found on several news sites about space and astronomy, and the first item being the Rosetta Space Pro once more. Last week news, we discussed that the Rosetta Space Pro was on its way to Comet 67P Churymunov Gerasimenko. And this week, or formerly last week, because this video was out on August 11, it has been confirmed that the probe has now officially arrived at Comet 67P. Now, I have already told a lot about Comet and how it works, so I'll keep that pretty short. But basically, for a probe to get into orbit around such a small stone, it's just basically a rock with ice and snow, it's quite a difficult thing to do. First of all, the probe had to rendezvous with a comet. And basically, rendezvous is that a space probe tries to get as close to an object as possible, gets the same speed as the object so it will not fly by it, or the object will be faster than it, so it has to be at the exact same speed to approach the comet as close as it can. And because of the extremely low gravity, it will have to get into an extremely low orbit, like just 50 kilometers above its surface, to actually be able to circle around the comet. Imagine, for a reasonable orbit above Earth, you need to be about 400 kilometers, like the ISS, but around this comet you need to be extremely close to it, like this. This is quite a well representation of how Rosetta will be circling this tiny piece of rock. Now Rosetta, the Comet 67P looks quite different from this rock. This is just a random comet because 67P does not exist in this simulator. So I'll show you a picture of it. Here's how it looks like. That is Comet 67P, and Rosetta also carries with him a small lander probe, which will actually attempt to land on a comet, something that has not ever been done before, so that's going to be quite amazing. If everything goes well, this small tiny probe should land on the comet around September or October, so that's going to be quite amazing. You'll probably hear more from Rosetta in the coming weekly space news episodes. Another very interesting thing that has happened in the news of space last week. A Spanish telescope, to be exactly somewhere in the south of Spain, has discovered a planet around a red giant star. Now, you can guess from the name that such stars are quite big, and to explain the difference in size, I have in front of us the sun, without any lens flares or regular brightness, because normally the sun would look like this. But I decided to turn off the so-called diffraction spikes, and now it looks like this. Just this tiny white ball in the center of the screen represents the real sun. A tiny ball, and we're about a 1 astronomical unit away from the sun. And 1 astronomical unit stands for about 150 million kilometers, which is the average distance planet Earth circles the sun. So, for your own reference, if you have, for example, 2 astronomical units away from the sun, you're about 300 million kilometers away. That's how math works. So, to compare the size of a red giant with the sun, we actually need to visit a red giant in this simulator. That's going to be quite amazing. And looks like this is actually a red giant. We're going to approach this star to about the same distance as the sun, so 150 million kilometers, and you'll notice the difference in no time. This is, well, let's actually get to the real 1 astronomical unit distance and see the difference in size. This thing is huge. And why is this particular star so interesting? Not just because it's a red giant, but first of all because this planet is in an exceptionally close orbit to this star. It only orbits in 6.25 days, which is incredibly short. It's in fact a Jupiter-like planet, so it's a gas giant, and scientists think that the planet will actually be swallowed by the red giant, because the red giant is basically a yellow dwarf like our Sun at the end of its life cycle. When that happens, and all core fusion activities have come to an end, the star will start to swell, it will start to increase in size and cool down. And as it gets bigger, it may just swallow any planets that circle around it. This is basically the future of the Sun. But don't worry, because that will only happen in like 5 billion years. So that's quite a while away from now. So yeah, the planet will be swallowed by this enormous star. You can see that it's no longer a proper round object, because it had become so big that the gravity cannot properly hold together the outside of the star. It will become probably even bigger, and at the very end of its life cycle it will blow away these huge red and orange outer layers and become a white dwarf. And to realize a white dwarf like Sirius... No, that's not true, it's not a white dwarf, it's just a white star. I kind of forgot which ones were white dwarfs. Oh well, a white dwarf is basically even small, way smaller than the Sun, and it's the final stage of the star's life. And then we continue in with the short news. You may have realized from the beginning of the video that there is another space probe somewhere here in space. It's called New Horizons. New Horizons' mission is actually to go to the dwarf planet Pluto. You may have heard from Pluto because it is in fact quite a questionable object, as it has never ever been seen, properly seen by the human eye, because it's so incredibly small and so amazingly far away from the Sun. It was only discovered in 1930 by Clyde Tombaugh, who accidentally discovered it by just looking at the stars with its telescope and trying to find which one of those stars moved in the night sky over several days. When he found that tiny star moving, he learned that it was actually a planet. But in 2006, Pluto has been, well, demoted to dwarf planet because it did not meet the proper criticisms for being a planet. That probably should be explained in another episode, or maybe you can ask a question about it in the comments so I can actually explain it more into detail. But what happened is that New Horizons is on the way to this planet to actually capture the first good images of the planet Pluto, because the best image we have gotten so far is this one. Now what you see here is not a true representation of Pluto, because this is how Space Engine renders it. This is how it may look like, but it can be something completely different. Either way, New Horizons is due to arrive in July next year, 2015. And it has already captured an image of Pluto and Charon orbiting each other. It's probably not a good image, I have not seen it and I don't know where to find it. But as he comes closer, the images will get progressively better. Now you can see that Charon is quite big compared to Pluto, and even Pluto is getting affected by its gravity. As you can see, Pluto itself has a small orbit around the center of mass. The center of mass is basically the central point of both objects. Now because Charon has a mass, it pulls on Pluto. So if we start to move up time, speed up time, you can see that Pluto orbits around this point over here, the central point of mass. That is the central point of both objects. It also happens with the Earth and the Moon, but on a much smaller scale, because the Moon is smaller and the Earth is bigger, while Charon is actually 25% the size and mass of Pluto. The other short news is about another fascinating planet. While on the first sight it may look like a very boring planet, this is Uranus. Bad puns aside, by the way. Uranus is a special planet because it does not rotate like many other planets do. In fact, it's like this planet has fallen on its side, and you can see it if you speed up the time. If you look really well, you can see those tiny light bulbs, those tiny bits around the planet moving vertically up and down instead of to the left and to the right. This planet is rotated in such a way that the north or south pole is able to face the sun. This circle over here you can see is either the north or the south pole, and same goes for the other side of the planet if you look really well. That is the weird thing about Uranus, but what I have discovered recently are a bunch of huge storms actually creating on Uranus. So the weather forecast for this planet will be a very, very stormy weather, because storms on gas giants like this can easily have wind speeds of up to 1000 kilometers an hour. So you definitely don't want to be around there when that happens. For the first time, actually, I am going to introduce here the questions from the comments, simply because it was not possible last week as it was the first episode. So here we are, and I actually had received a question from YouTube user TheSonicJoey, aka JSLGaming15. He asked, how do most planets get their names? Which is actually a very interesting question, because you can divide the planets that get their names into two sections. First of all, the planets from our own solar system, which receive the names from Roman gods. Which is kind of strange, as Romans were not the scientists who discovered these planets. In fact, the visible planets from the Earth, Mercury, Venus, Mars, Jupiter and Saturn, have probably been known for much longer than Greek or Roman civilizations. But the thing is, they didn't realize they were planets back then. The Greek got an idea of those being planets, but it was not until the 15th or 16th century, like when people like Galileo Galilei discovered they were truly planets and not just stars like all those other bits of light in the night sky. They all got Roman names. For example, Mars, which got its name from the Roman god of war, or Venus, who got her name from the goddess of love. Same goes for Jupiter, Saturn, Uranus and Neptune. Now, in case you're wondering, Pluto did not get its name from that fancy dog of Mickey Mouse. No, in fact, it got its name from the Roman god of the underworld. Think about that for a while. Now, the second part of the naming of planets is exoplanets, and as you know, exoplanets are planets that orbit another star. Let's actually pick an example. For example, this planet. Here it's called HIP 112181-4. Why is it named like that? Well, first of all, the name of the star is HIP 112181, and then, based on the time of discovery, each planet will get a number. So in fact, these planets don't even have proper names, they just have numbers and letters, so they're very boring names. So I leave it up to you to think of fancy names of planets that have actually been discovered. The other thing is, though, that most exoplanets discovered these days are called Kepler and then a number and a letter. Let's take for example Kepler 10, which is the name of a star discovered by the Kepler telescope, which actually makes a lot of sense, as the Kepler telescope is the telescope orbiting in space to find exoplanets around other stars. So here's Kepler 10. The first planet discovered by Kepler was Kepler 10b. Why not A? Because star is practically A, then comes the first planet, which is named B, then C, and eventually, if this discovers more planets, it will become Kepler 10d, E, F, and so on. So that is how those planets get their names. I know, it's not very original, it's in fact pretty boring. Some got actually nicknames, like Methuselah, who is apparently the oldest planet in existence, and is named after a person in the Bible who became very old. But other than that, there is not many names that have been given to these planets, probably because there's been like 700 exoplanets by now, and to name all of them is probably pretty exhaustive work, and I don't think scientists are that creative with names, so I'll leave it up to you to come up with some original names of exoplanets. So my question to you is, how would you name a planet if you discover it? Leave it in the comments below and let me know. Also, make sure to ask new questions so I can have another question from the comments next week's episode. For this week's place to visit, I'm taking you to another piece of software called Stellarium. Stellarium is actually an amazing piece of software for those who like to observe the night sky and would like to have a very easy program to learn themselves to guide across the night sky. Stellarium is very useful for that, as it shows constellations, where the planets are at what time of day, where the moon is, what phase it is, and all those amazing things. Now I wanted to bring you here because something very special is going to happen next week on the night of August 12 to August 13. So basically from Tuesday to Wednesday night. At around midnight on August 13 local time, we'll have a meteor swarm reaching its peak. Now for those who don't know what a meteor swarm is in fact, I'll shortly explain. As in fact, on the orbit of Earth, there's a few clouds of dust, very tiny particles, very tiny pieces of rock, called meteor swarms. And when those meteor swarms pass through the atmosphere of planet Earth, you'll see them as shooting stars. So you could basically say that on August 13 midnight, we'll see shooting stars, and in fact it will reach its peak at that night. You can already see them if it's a bright and dark sky. But those will probably not be many. In fact, you can probably see over 30 per hour when it probably reaches its peak on this night. Now, why are they called the Perseids? Because they appear to come from the constellation of Perseus, which is this fancy constellation over here. If you want to find it in the night sky, you should first go and look for Ursa Major, which is quite an easy recognizable constellation. It looks like this. This is the most familiar part. You've probably seen this constellation over and over again. Then you go and follow this line, just follow my cursor, you'll arrive at Polaris, which is basically the northern pole star. Then you continue to the right and you'll end up at this W-shaped constellation, which also is pretty easily visible in the night sky, called Cassiopeia. And just below Cassiopeia is the constellation of Perseus, which looks kind of like a airplane's propeller, but then just a little longer and misshaped and stuff. You probably couldn't fly with that thing, but oh well. If you look over there, you should be able to see shooting stars, but it has to be a dark and bright sky. No clouds, preferably no streetlights, otherwise you're going to have a hard time seeing those shooting stars. And that is why this is the place to visit, a place near your own house, which has not many streetlights. And on the northern half of planet Earth, at midnight on August 13, you should see shooting stars. Alright my dear watchers, that was it for this week's weekly space news episode. I hope you enjoyed it. Leave a comment in below and possibly like or subscribe to me if you haven't done so already. That would be greatly appreciated. And don't forget, feel free to leave comments below the video and ask me questions, because I love to answer them. It doesn't matter how stupid they are, because I can perfectly understand astronomy in space and all around it is a difficult subject to understand, but that is what it makes so fascinating. Thanks for watching and see you next week.